Okay, here's example 3 for area between curves. We're finding the area between y equals cosine x and y equals sine x on the interval from 0 to pi over 2. So in this case, we have been given a specific interval, which is good because we know cosine and sine will go on forever and keep oscillating. So we've cut that down a little bit here. Okay, so in the axes here, you can see I've graphed the cosine function and the sine function. They're not necessarily the most accurate graphs, but we know cosine starts at 1 and then goes down to a value of 0 when x equals pi over 2. And sine does the opposite thing. It starts at 0 and then curves up to a value of 1 when x equals pi over 2. So we are going to be looking at the area trapped between those two curves on this interval from 0 to pi over 2. Okay, now notice that those curves do intersect in the middle there at x equals pi over 4. You can find that because that's the only point in the first quadrant where cosine and sine have equal values, is at x equals pi over 4. Okay, so the area that we're going to be looking at is between our two curves, and the shape looks kind of like a pair of wings or something. It's this area in here. Okay, notice that I'm not including this part down here because that's not between the curves. That's between the curves and the x-axis, which isn't what we were asked for. So it's just the blue shaded region. Okay, now you might notice something a little bit interesting here. When we're determining our top and bottom functions, it actually switches halfway through. Okay, when we're starting out from 0 to pi over 4, the cosine function in black here is on top. So that would be our yt over here is the cosine. And then our bottom function over there, the yb, would be the sine function, which is graphed in purple there, kind of a dark purple, so sorry if you can't see that too clearly, but that is the sine function coming in on the bottom there. But notice as soon as we pass the intersection point, then that switches. The sine function is on top now, and the cosine function is on the bottom. So if we're setting up our integral here, we would actually need to do two different integrals to find the area. Okay, because you always got to do top function minus bottom function for the setup. So we would have to go from 0 to pi over 4 using cosine on top. Cosine x minus sine x dx. And then we'd have to add that to the second integral to cover the rest of the area. From pi over 4 to pi over 2, that's where sine is on top. So we do sine x minus cosine x dx. Okay, and if you're cool with that setup, that's fine. You can go ahead and do both those integrals and it'll work. If you don't feel like doing two integrals right now though, there is a shortcut that we can do. Notice how our area, it really does look like a pair of wings, something like that. There are two identical halves to this total area. We've got like this wing over here and then this wing over here. They are exactly the same size and shape. So for our shortcut to this, we can use some symmetry of the area that's graphed there. We have two identical halves. All right, so that's what I'm gonna do here. I'm gonna just find one of these areas. I'm gonna do the first one because it's got a nice 0 in its lower integration limit. So we can just find one of those areas and then double it to get the total area between the curves. All right, so I'm gonna do it this way. I'm gonna do twice the area from 0 to pi over 4. So that's where cosine is on top, and subtract sine, which is on the bottom. Okay, that seems nicer. And now we'll do our antiderivative. Antiderivative of cosine is sine. Antiderivative of negative sine is positive cosine. Watch those positives and negatives on these. Remember that you should be able to take the derivative of what I just found and get back the original integrand. So derivative of sine is cosine, check. Plus derivative of cosine, which is negative sine, check. Okay, so that's good. All right, and then we're going to need to plug in our limits, 0 and pi over 4. All right, so let's do that. Remember to keep that 2 out front since we're using symmetry. And we'll plug in pi over 4. Sine pi over 4 plus cosine pi over 4. And then subtract and plug in 0. Okay. Then we'll put in the values of those trig functions. Sine and cosine of pi over 4 are both the same value. It's root 2 over 2. So we got root 2 over 2 plus root 2 over 2. The sine of 0 is 0, so that's gone. And then the cosine of 0 is 1. So we're going to be subtracting 1 there. All right. And so we've got 2 times root 2 plus root 2 is 2 root 2 over 2. Okay, minus 1. Definitely simplify that. Okay, so we'd get 2 times square root of 2 minus 1. And you can leave it in that form, just like that. That would be a fine answer. If you wanted, you could also distribute the 2 and say it's 2 root 2 minus 2. Either way, totally a-okay. All right. So again, if you did the 2 separate integrals where we switched the top and bottom functions, that is also fine. You should end up with the exact same answer, so you might want to try that out. But if you spot a shortcut like this, it can be helpful because we only had to evaluate one integral that way.